Okay everyone, this is video 1 for your physics revision, for your assessment on the waves topics. We're talking about types of waves here. So remember, waves are split into two different types, whether they're transverse or longitudinal. Make sure you can describe what that means in terms of the direction of the oscillation that's making the wave relative to the direction of the energy transfer. So key to this is in transverse waves, the oscillation is at right angles to the direction of energy transfer, an up and down motion, whereas in a longitudinal wave, the oscillation is backwards and forwards, oscillating parallel to the direction of the energy transfer, a backwards and forwards movement. Remember that light and all of the electromagnetic spectrum are transverse waves, and sound waves are longitudinal. When we talk about mechanical waves, like the waves in a piece of string or in a spring or in water, they can either be transverse or longitudinal depending on the direction of the disturbance. Make sure you can use the words shown on this diagram to describe the parts of a wave. The amplitude is the height of a wave. Notice it's measured from this central line of symmetry. The bigger the amplitude, the more energy a wave has. A wavelength can be measured in different ways, but is always the distance between 2 points of equal disturbance. So the length of one complete oscillation, up, down and back again. And we talk about peaks and troughs. Now the wavelength relates to the frequency of a wave, and the frequency of a wave means how many wavelengths are there in 1 second. And so this equation here, which is on your equation sheet, is showing you that the amount of time that one wave takes is 1 divided by the frequency in hertz. So for example, if a frequency was 4 hertz, the time for one wave would be 1 divided by 4, which is 0.25 seconds. The equation that links speed, frequency and wavelength, make sure you could rearrange that if you had to, and make sure that you're confident about using both very large and very small numbers if necessary. So our worked example here is calculating a wavelength. We want the wavelength. We need to do the speed divided by the frequency, and these numbers are in standard form. So make sure you can put numbers into your calculator in standard form and that you can interpret the answer you get. You might be asked to express your answer in standard form, which I have here, or convert into nanometers or micrometers. Remember, a nanometer is times 10 to the minus 9. When we're talking about wave behavior, the two most common types of wave behavior are reflection and refraction, and we'll talk about these in more detail later. But for now, remember that reflection is waves bouncing off surfaces, and when that happens, the angle that the wave hits the surface at will be the same as the angle it bounces off at. In refraction, which is caused by a change in speed, a refraction is the change of direction of a wave as it crosses a boundary and changes speed.